Hi, everyone. Thanks, Mel, for the introduction. So I'm Ben. I'm a developer on Fusion. I used to work with James, actually, who did the previous talk. So if you want to ask questions about specs, you can ask him, and I can talk to you about GraphQL. So how do you build your APIs today? Look, I can probably guess how you're building your APIs. I think we're all doing it more or less the same way. And we're going to be using REST. Put your hand up if you're building a REST API. I can see some people haven't got their hands up. Are you still using like a SOAP or something? No? Or I've already sent people to sleep. Is that what's happened? OK, so yeah, REST. Been using it for what, 20 years? Roy Fielding's PhD was 2000. We know how it works, right? You see a HTTP method of, say, get, you know it's going to be a get operation. You see a post, something's probably been created or modified. We have addressable URIs, so we know that when you look for paths, the paths usually have a meaning. So you know that you'll see a path for, say, /user, it's to do with users. And status codes have kind of become a lingua franca for what does it mean for a response. We see a 500, something's happened on the server, something's gone wrong. We see a 200 series, that's a success. So this is a successful pattern, right? Been using it for 20+ years, lots of successful products. So why would we shift to GraphQL? Why do something different? Why try something that's only been out maybe a few years, well, really 4 for the spec and maybe 6 or 7 for the internal implementation at Facebook? So just a bit of background first. This is the reasons that people look to adopt GraphQL. So there's over and under fetching, latency, and mobile. So I'll give a quick intro to some of these things and how GraphQL solves it. So overfetching is the idea that I want to fetch, just say, the user's name. I hit the user's endpoint up there, and I get back this whole chunk of JSON, which is stuff I don't actually need. So we've paid network costs, both in time and money, to fetch data we're not using. And then the opposite, being underfetching, is where I want the name and I want the address, and I have to issue 2 requests. So not only have I got the extra data I don't want, but I've had 2 network hops to get the information I actually want to display. So this leads to greater latency. So things get a little bit slower. You're making more calls. If you could push this to the server, this would be a little bit quicker. And then this really comes to a head on mobile. So mobile is one of the driving factors behind this sort of introduction of GraphQL, because OK, you can get away with some of this stuff if you've got, say, a fast, wide network internet connection. But if you're on a mobile, it's likely to be slower, or it's likely to be more flaky. So problems with chatty requests and things become much, much worse. So that's just some background on GraphQL. But what actually is GraphQL? Well, its name, as it suggests, is a query language. So what does it look like? You get a query that looks like this. So we're saying we want their person with ID 123, and we want their name and address. And of the address, we just want the street. So we ask for that, and that's all we get. So you get one request with a reduced payload size. So you're getting just what you asked for. So this works also to make it a bit more flexible, where you don't have to sort of build custom cut-down clients for each usage case where you want just the data that's there. You can sort of get the client to say what it wants. So there's 2 major components to GraphQL which help you understand the rest of this talk. So the first one is the schema, and then there's the execution engine. So the schema, it tells you, what questions can I ask this API? What can you tell me about? And so in this case, we've got a person, and that person contains some scalar types or primitives. So we've got the name, the date of birth, and the address. So these are just basic primitives. There's numeric types as well. And then obviously types can contain types, so you can get a rich graph of things. So the address contains more primitives, and you just chain these together to represent. This is a standard data model. Anyone who's worked with some form of type systems will be very comfortable, very familiar. And just to tie it off, the query parameters are done in the brackets. So it's JSON, but not quite JSON. And that's how you say something like, I want an ID, which is a specialized string type. So the execution engine itself. So first of all, it's responsible for the query parsing. It takes your request, it breaks it up into all the fields you requested, and works out what you've asked for. So that's the first stage. Then there's the data fetchers or data resolvers. This terminology can change a little depending upon your chosen implementation library. I think the Java one might use resolvers or fetchers. Anyway, the way you think about this is just to say, at these various points of my schema, I want to attach some code that executes to fetch that field or that entity. So we might put a person resolver in for the person entity, and that will fetch person information. And then lastly, the engine runs these things in parallel. So it puts it all back together after it's sort of fanned out. So it's like a fan out and then reduce back into one thing. So that's roughly what the engine does. So that's pretty straightforward, right? We'll stick that on the HTTP path, and we're done. The engine will take care of it. We'll just write a schema. Of course, if that was the case, I'd have a pretty short talk and I probably wouldn't be here. So, design patterns. First sort of starting point when we're looking at our API. So some common things here, schema evolution. We have to do that with all APIs. It's a fact of life that they change. We may not like it, but it happens. So GraphQL can be a bit more flexible in the sense that you don't sort of have multiple endpoints you need to move and manipulate over time, multiple requests. You've just got a schema where you can add at least types without making any breaking changes, which is similar to REST. You can make additive changes. But because it's one large body of schema, it's a bit more easy to do that. But in doing that, you find that, this was a bit weird when I first encountered it as well, it's actually better to often use types rather than the primitive objects to get your API a bit more flexible over time. So I'll show you what I mean by that with that person example. So we look at person, and we wanted to say, add something to name. So we wanted to give it a given name, last name, surname, some extra name field. We can't really modify name without breaking the current API. We have to sort of dump some extra fields onto that type of person for given name and so forth, which leads to a bit of a cluttered or clumsy API over time. If we look at address, we've kind of at least contained that. So in address, we can add, say, I don't know, country, postcode, telephone number, which is not really an address, but you can put them inside that type. So it gives it a little bit more flexibility over time. So this is sort of one of the recommendations that's come out is to use a type rather than a primitive where possible. And the last thing you can do from a schema evolution perspective is you can actually monitor the usage a bit more fine-grained compared to a REST API. So in REST, you can probably tell, you're trying to deprecate something, you do the usual thing, you say, hey, everyone, send emails, we're deprecating, you do that for a year, everyone ignores you, you turn it off, everyone goes and logs support tickets and yells at you. Everyone's seen that happen, right? You've done that at some point? Come on, someone's done it. Who's had that happen? Come on. There we go, someone's had it happen. Right. So I can't fix your users with GraphQL, but what we can do is we can see a bit more fine-grained what they're using, because instead of seeing what paths they're hitting, we can see it at a field level, so you can work out when fields are safe to delete. All right, next topic that will come up is pagination. So you can't just have APIs that just return absolutely everything, because the limit then just becomes the point at which your server melts down, right? You have to put pages or some form of cap on what you're going to return. So in GraphQL, there's a framework called Relay, or Relay.js for GraphQL, which is mainly about building clients for GraphQL applications. And what they've built is a thing called the cursor specification, which kind of morphed into a de facto standard for pagination. So it's reasonably involved, so I can't go through the whole thing here. I want to just make sure you're aware it exists and give you some of the key ideas out of it. But yeah, if you choose to build a GraphQL API, check out the Relay spec, because it's pretty standard across clients. So there's first of all, on the request side, is the connection and the node. So these are interfaces in the GraphQL schema, and so by using them as an interface, that allows you to build a client against that. So this is how the clients work in a standard manner against GraphQL schemas. So connection represents the things we want to retrieve as a collection. So the connection is where you do things like, I want a page size of 10, and I want the next position from this point. The node is the actual elements you're getting back. So this is where you'd say, I want name, address, phone number, ice cream, something like that. And then on the response side, the page info is where you get back information about, okay, you had 10 results in this result, you have a next page available, you have a previous page available, that sort of thing. And the cursors, your pointers to say, I want the next 10 from this point. So again, I can't go into this in huge detail right now, but if you do look at it, check out the Relay spec afterwards. Now, mutations are the last part here. Mutations are how you do a modification in GraphQL. So mutations have a few interesting things. So first of all, you can't actually group your mutations into a hierarchy of types, because the GraphQL engine doesn't actually provide guarantees about the order of execution when those requests get fanned out. So what I mean by this is you couldn't have person with a mutation and then have person create, person delete, scoped within some kind of person container. You have to put it all at the root level as person create, person update, person delete, and do it by namespacing with names rather than sort of a container. But I've heard apparently that might change. So if it does, they'll make things a bit easier. The second one, similar to on the query side, you can have a single, multiple input parameters, but if you put say 20 fields in the input type, it gets quite clumsy to work with. So a single mandatory input type is usually a bit more flexible and a bit easier to evolve over time. And then lastly, similar to REST, if you can return the affected object or return the fields from it, because it's meant to be a querying language, so you can create the person and return back what you needed, or you can offer to return back what is needed, and the client will take what it needs. So you can say, return the person's ID, name, address, everything, right? And if the client doesn't want it, they don't need to ask for it, and then the work doesn't need to get done. So on to things about running a service. So this is assuming you're operating something that's hosting a GraphQL API. So, one of the first things you'll ask when you're running a service is monitoring, right? We need to know if our service is up or down. And with REST, we kind of know how to do that, right? This is a dummy REST access log, but we could probably all look at that and go, okay, well, we've got 2 failed requests in there. We can see something's going on with like hello world. There's like user creation going on. You can get a quick feel for what's happening with a REST API log. But if this was GraphQL, because it's all handled inside the engine, it just looks completely opaque. It's just a series of 200s to this one endpoint, which is basically useless. So what we've done is inside the error handling in GraphQL. So we're looking at error handling side, but you can also treat this for success cases. GraphQL has a standard structure for error handling, and part of that is the extensions object, which is basically a bucket you can stick your own extensions to the response in. So within that, and this will apply to any sort of GraphQL engine, has a way of customizing error handling. We've applied our own custom error handling to attach a HTTP status code, because most of our use cases have been calling a downstream system that has a REST API on it. And so we can customize it to return that in the response, which lets us see what's going on. But also because we have an error handler hooked in, we've got part of that handling is to fire metrics. So I'm going to assume people are familiar with something like StatsD or SignalFX or Wavefront, Datadog maybe. Those are solutions for, you fire off something from your server to tell the monitoring solution, hey, we've had a successful request, we've had a failed request, successful failure. And those things plot them in charts and do alerting. So what we do is when we customize the error, we also fire off to our monitoring solution to increment those counts in our monitoring systems. So the other thing is access logging, which is similar to our monitoring solution, which is when you have a security incident, the security team is going to want to do something like, okay, give me your access logs, right? They're going to want to see what's been breached, what's been exfiltrated, and you'll give them something like this, and they're going to be able to see, okay, we think that the attacker's created a new user, we're going to go delete that account, or whatever they've done, right? The security team has usually got some tooling around this. But with our GraphQL log, they're going to go, what is this, right? This is useless. So if you look at the GraphQL query, though, it does tell you what's been asked. The only thing that's kind of secret or sensitive or you wouldn't want to tell anyone about is that query parameter. So if we drop that query parameter out, we can put that into the log. And so now we can produce something in our application logs kind of similar to a HTTP access log. I haven't really looked much at the tooling around this, but it's not going to be the same level of sophistication as you get maybe with some of the current stuff of HTTP access, but you'll be able to produce something similar. And you'll be able to at least get a sense of what's happened during an incident. So lastly, we want to look at tracing. So if we looked at a REST API and asked you which one's your slow-performing service or slow-performing endpoint, you'd probably have some HTTP logs or something, and you'd say, right, I can see /person is slow. We'll go and we'll instrument person, and we'll find out why that REST endpoint is slow. But in GraphQL, that's not going to work, right? We're just going to see, okay, some requests are slow, some requests are fast on that /GraphQL endpoint. And this is because it's all field level now, so not all those fields are equal. So what we need is something to be able to get in and say, running the resolver for person took X number of milliseconds, and running for address took something smaller or greater. So one format or tooling is Apollo. So Apollo is a GraphQL framework. They also have a hosted solution. And part of what they've come up with is this thing called Apollo tracing, which the format is kind of getting used in a few other libraries now as well. So the tracing format is basically using that extension structure from before, except this time they've put a tracing element in it. And so what you do is, I think most of the execution engines support something like this. It will fire off a start time and end time, and then also what you're really going to be interested in is this resolvers section, which I didn't have time to fit, or space to fit in the entire slide. And that will give you runtimes for the different resolvers. So that's how you can start to get a picture of what took so long with this request. Was it retrieving the person? Was it retrieving the address? And then again, because you can hook into the tracing to customize it, you can start firing metrics about which endpoints were slower or which endpoints were faster. Okay, now tooling. This is the last pro section I'm going to cover. So GraphQL is an IDE, well, they could say it's an IDE for writing GraphQL queries. Looks a bit like this. So if you've played with a GraphQL, like a public GraphQL API from someone else, you'll probably have found something similar to GraphQL. It's very ubiquitous through the industry. and it's proven to be quite a nice way to interact with GraphQL APIs. Personally, I find it quite nice and discoverable. You can explore the schema. It's quite easy to make the requests. It's quite easy to see what is available. So have a look at installing GraphQL when you set up your API. It's pretty straightforward. The next thing I recommend you look at is schema validation. So this comes, probably, I think most of the libraries for building GraphQL applications support this. And what you want to do is you want to have something that pulls down your current production schema and compares it to the one that you're running in development. So the reason to do this is it's very easy to, say, slip in a change to make a field mandatory when it used to be nullable. And if you do that, you're going to break the clients because their queries are no longer going to validate. So have a look at what your chosen implementation supports and try and get some form of schema validation in place, just so that you can put a stop to shipping breaking changes through like an automated build process. The last thing I'd suggest is there's some pre-built gateways available. So I mentioned Apollo, who have a hosted solution. Amazon's got AWS AppSync. So these are pre-built GraphQL solutions, and their features will differ, but they generally will solve that problem of having a GraphQL endpoint interface in front of your existing REST APIs. And so if you looked at one of these, and if they're appropriate, it might help you with picking off some of that operational stuff I mentioned about monitoring or some of the tracing elements. So that sort of stuff might get solved for you. You can just focus on building your API and get the schema out there and start on that part. So this may be appropriate. It might be a fast way to get you going. So that's all I pretty much wanted to cover. This is a quick summary. So we've talked about designing. So that was a bit about schemas, patterns for evolving APIs, a bit about operating, so how you monitor, how you trace through a GraphQL tool, and then lastly, tooling. So things that might make your building of a GraphQL application a bit easier, a bit more usable, a bit nicer for you. So I've got about 3 minutes left, so I've got time for Q&A. I've also got a slide here, which is, it's a wall of text. I've been told not to do wall of text, but here it is. So it's all those things I've mentioned during this talk, just in one slide. I saw a few of you taking photos in the middle. This is just a summary of some things you might want to look at afterwards. So